So first, we are supposed to draw the graph of y equals 2 to the power x from negative 3 to positive 3. You must first set your calculator up properly, like I always say. So it's 2, then to the bracket, to the power, open bracket, and put in the x coordinate one after the other to compute your y values. So you can pause the video and try it yourself. Okay, let's carry on. So these are the answers. You got them right. Now, we need to try and plot the points as close to the right position. On the grid, we know 5 squares make 1 unit. Therefore, each square is 0.2. So you need to try and plot within the right confines. Though you might not necessarily be perfect, try and get it close to the right place. So these are the points: negative 3 and 0.125, negative 2 and 0.25, and so on. You join with a smooth curve. So that is the graph of y equals 2 to the power x. Before we explain anything further, let us try and draw on the same grid the graph of y equals 2 to the power negative x, so we can compare and see what is happening. Set the calculator up this way: 2 to the power negative outside, then you put the x values in bracket. These are the answers. Let's plot them. Join with a smooth curve. Okay, so what is the first thing that you realize? Remember, we said a typical y equals b to the power x will go through point 0,1. That is the y-intercept. That's the first thing. Second, we said all the values of y will always be positive. As you can see, there are some of them. This one is very close to 0, but it's not 0 yet. So you could see that we call horizontal asymptote. That means if keep on decreasing the x, the red line will get closer and closer and get closest to x, and this one too will get closest to x as you increase the x values, but will never cross the x-axis. So the x-axis, or y equals 0, becomes what we call the horizontal asymptote. So we say the two graphs are asymptotic to the x-axis. The two graphs are asymptotic to the x-axis. What it means is that they will get closest to the x-axis, but will never touch or cross it. Second thing is, you see the red line, y equals 2 to the power x, is increasing as x is increasing. So we call this exponential growth function. And the pink line, you see that as x is increasing, the graph is getting smaller, or the y values are getting smaller. So that is the exponential decay. So you now know the nature of exponential growth function and exponential decay. Okay. Now, the last thing you can say about this is that you could say y equals 2 to the power x and y equals 2 to the power negative x. One is a reflection of the other in the y-axis, sorry. So it's a reflection in the y-axis. So we can say the graph of y equals 2 to the power negative x is the reflection of y equals 2 to the power x in the y-axis. In the y-axis.